Good morning. Today we are going to start Unit 8, which is where we are going to talk about general oblique triangles, and we are going to use the law of sines and law of cosines in this unit to solve oblique triangles. So today we are just going to focus on the law of sines. Today is broken up into two lessons, really covering basic straightforward problems, and then later referring to something known as the ambiguous case. So first, in our warm-up here, we have some problems that are going to help set us up for success to do well, and here we have a proportion. So the proportion is asking us to solve for x. So when you solve a proportion, a lot of people will say cross-multiply the diagonals. So you have 3 times x, so 3x, and 2 times 7 is the diagonal, which is just 14. And then you always have to divide to get your x by itself. So divide by 3. So x is equal to 14 over 3. Now, there is also another way of looking at that, because when you solve a proportion, you are always going to multiply the pair of numbers that you know. And you are always going to end up dividing after you multiply, which is how the math works. So if you are able to identify which numbers you multiply together, so in this case you always will multiply the ones you know, so the 7 and 2, and then the one that you actually will end up dividing by is the 3. And we will use this strategy a lot to speed up a lot of our math when we solve a law of sines problem. So case in point, here, if we know that we want to solve for y, that means we are going to get y by itself. So I'm going to multiply the 3 and the 5 together, and I'm going to then end up dividing by x. Okay, so in the end, I bet my answer is going to be 15 divided by x, and that's going to equal y. But let's see if my shortcut kind of works. So if we take our time and we multiply our diagonals, we'll have 3 times 5, that's 15. And then if we multiply the other set of diagonals, we will have x times y. But we're solving for y, so we want to get y by itself, and that would require us to divide by x. Y is equal to 15 divided by x. Hey, that's what I was saying was going to happen. So knowing how to solve a proportion in a speedier manner can be very beneficial to us. The second thing that is going to be helpful today is to refer back to inverse functions. So if I have an angle here, and I am interested in knowing that angle, and I know 2 sides of a right triangle, we can use inverse trig. So if my stick figure is standing here, that would make my 3 the opposite and my 4 the adjacent. So technically, tangent of theta is going to equal the opposite divided by the adjacent, so 3 divided by 4. But I'm looking for the angle, and anytime I'm looking for the angle, I will use the inverse, not sine, tangent, in this case, of 3 divided by 4. And I will put that into a calculator. So let's see, does my calculator show up here? It does. Please make sure that you are in degree mode so you can see that I'm in radian mode. So I'm going to go to my mode, and I'm going to arrow down to degree. All of the problems this unit need to be in degree mode. So second tan will give us the inverse, or arctangent, and we'll take 3 and divide by 4, and the angle that we get is 36.86 degrees. So theta is equal to 36 point, let's round it up to 9 to the 10th. Okay. So using the inverse trig functions is going to also be very powerful. So far, prereq skills, we've got solving proportions, and we've got inverse trig. Now we're going to start getting into the nitty-gritty of what we will be looking at when it comes to oblique triangles. So the next few minutes are going to talk more about conceptually what is the law of sines, how do we look at these triangles, and how do we set them up to solve our problems. So, what types of classification triangles have we been dealing with? This whole semester with our trigonometry, technically we have always been using right triangles. Okay. And that is no longer going to be required. Using the law of sines and the law of cosines is a way to deal with non-right triangles, and the word we used for that is called oblique. Second thing that we want to recall is, what does congruence mean, or congruent? And we're just looking there to say that the sides are equal. Okay, so if we looked at two triangles and those sides were congruent, the two sides would be the same value. They would be equal. We can also say the angles are equal. Okay. Moving along, also, when it comes to geometry, you learned a lot about similar triangles and proving triangles were congruent. And there were some ways to prove that two triangles were congruent. The first of which was the SSS. Okay, and this stood for side, side, side. Then another one, we have side, angle, side, SAS, which was side, angle, side. The important thing about SAS is the angle is in the middle. Okay, so in a picture, your angle is always going to be between your two side lengths. The third one is ASA, which is angle, side, angle. We'll talk visually about what these mean in a moment. Fourth one is side, angle, angle. SAA. And those are going to be our four congruency theorems that we're going to focus on when we solve these general oblique triangles. Sorry about that. Pause the video if you didn't get that from the video. I realized it was off the screen. All right. The next slide. So here I want to draw pictures of what these four congruency theorems might look like. So in a side, 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 if we have a general triangle, we would show that the three sides are congruent. Pretty self-explanatory if it's side, side, side. If it's side, angle, side, as I said on the previous slide, the angle must be in the middle. Okay. And there's lots of different ways you could use, as long as when you go around counterclockwise or, sorry, that was clockwise or counterclockwise, that you go in the same order. So if I start my sides here, then the angle would be there and then the side would be there. Side, angle, side. That's not the only representation, but that's one of them. ASA, the middle number here is, or the middle part is a side. So A, side, A. Make sure you're going in a clockwise or counterclockwise position. So side, angle, angle. Here's a side. Here's an angle. And then I have to skip over to the next angle. That would be side, angle, angle. Okay. And as I already mentioned, notice the names are going to follow a clockwise or a counterclockwise order around the triangle. So we've got side, 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 angle, side, angle, or side, angle, angle. But what that leaves out is everybody's favorite, AS. What about ASS? Well, we've got good news for you. Technically, there is no AS in math. So if you were to run across a triangle that was SSA, or backwards SSA is ASS, which how I will refer to it from this point forward, so it sticks out, you will create what is known as an ambiguous case, and we will discuss that more in our second video series. So what an ambiguous case means is the information that we know is ambiguous. It's not clear, based on the angle that was given to us, whether that will be an acute triangle, where all three angles are less than 90 degrees, or whether that same triangle will end up being obtuse, because this angle right here could be greater than 90 degrees. But in the end, remember, all angles must add to 180. Okay, so that's our triangle rule. So if you have an ASS triangle ambiguous case, it is possible that you have one triangle, two triangles, or the third reality, no triangle. And that would be because the length of one of the sides does not go long enough to meet the existing sides. We'll talk more about those in a later video, but I wanted to get those out there. So ASS, think twice, it's ambiguous. So our goal for this unit is we are going to understand and apply the law of sines and cosines to solve oblique and right triangles. To solve the triangles, that is the key word. When we solve a triangle, we are going to find all the angles and all the sides. So you could potentially be finding up to 6 things in a problem, maybe more. Okay? But keep in mind that is our ultimate goal, to be able to find all the angles and all the sides of any triangle. And I'm probably not going to, I shouldn't have to tell you to use the law of sines or the law of cosines. You're going to use the information given to structure what you will do for that. All right? As far as an oblique triangle goes, that's what we're going to be studying a lot of, and kind of already alluded to a lot of this information here. But an oblique triangle means we will have no right angle in it. So the two types of triangles that could occur are an acute, which means these are all less than 90, or an obtuse, one angle is greater than 90. Okay. Now let's move on to the actual law of sines. So when it comes to solving an oblique triangle with the law of sines, what we are ultimately going to be looking for are two types of situations. Either they're going to give us one side and two angles, so we can have the situation of angle side angle or side angle angle. So either of those are okay, or two sides and one angle. The one we really got to watch out for is the ASS triangle. That's the one we really got to watch out for. So, what is the law of sines? Well, first of all, the capital letters in this triangle, notice as you go around in a clockwise motion, the capital letters represent the actual angles. So, capital letters are the angles. And the lowercase letters are the sides. The important thing is notice angle B opposite it is side B. Angle C is opposite side C. And angle A is opposite side A. And that's going to be true for any triangle that we talk about this unit. So really being able to draw a picture, label a picture, and identify what information was given to you is essential. So now that we've talked about the different parts on the triangle, what they are, the law of sines states there are two ways you can think about this. The sine of angle A, notice I used a capital letter, divided by side, just side A. So sine of angle A divided by A, that is proportionally equivalent to the sine of angle B divided by side B, which is also proportional to the sine of angle C divided by the side C. Now, when we talked about our warm-up, our proportion was really just two fractions equal to each other, but we have three. And that's because you could compare the information in angle A to the information in angle C. You don't necessarily need B. Or you could just do B and C. Or you could just do A and B. They're all going to be used, but you only ever look at two fractions at a time, even though there are three in the formula. So in this case, the angles are all on top, and they're all divided by the side lengths. If you prefer, you could flip it. You could have side A over sine A equals side B over the sine of angle B over side C over the sine of C. There really is no correct way to do it. I will probably end up using both, and that is our law of sines. If you, for some reason, didn't do so already, please make sure you are in degree mode. Okay? You need to be in degree mode this entire unit. If you are not in degree mode, you will have some difficulty. Also, a lot of this unit is being able to use your calculator to successfully solve the problems. If you are not pushing the buttons into the calculator correct, you are not being very clear with fractions and parentheses, you will have difficulty solving these problems. Let's look at a problem. So here the directions are to use the law of sines to find a missing angle. Keep in mind, in the future, I shouldn't need to, if you're going to be 3.0 proficient, I shouldn't have to tell you to use the law of sines. Okay, and you're going to have to find everything in this triangle. In this case, we just want to focus on angle A. So angle A is right here. Okay. One of the things that can help us with regards to setting things up is to make a little chart. So I don't know angle A. Do I know side A? Do I know what's across from it? I do. It's 7 meters. We'll just use 7. They also told me angle B. That's 130 degrees. And across from angle B is 28 meters. That's all the information that they told us. Okay. We want to always analyze what type of triangle we are looking at. Is it side, side, side? Is it ASA? Is it SAS? Is it ASS? Is it a Nash triangle? Well, let's take a look. We have go in a clockwise direction, so I have an angle, and then a side, and then a side. So this is indeed an ASS ambiguous case triangle. However, because I actually gave us the picture, I do not have to check for ambiguous case. We'll talk more about that in the second video. So let's set up our law of sines. So I have this corresponding pair that I know for B. I know its angle and I know its side. So I'm going to take sine of A, because that's what I want to find, divided by side A, which is 7, equal to, proportionally, the sine of angle B, which is 130 degrees, divided by 28. And this proportion is what I want to solve. Now, always find the numbers that you know. I don't know this. This is my variable. So I'm going to end up multiplying these together. And then I'm going to divide by the 28. So sine of A is equal to 7 times sine of 130 degrees. I do recommend putting the degree symbol on, just to distinguish between degrees and non-degrees. It will help you in the long run. Divided by 28. That is mathematically what we are doing to get sine of A by itself. Now, calculator time. if you are not successful in entering this into the calculator, you will have problems. Okay? So, because we have a fraction, you could just go 7 times sine of 130, and then you could divide it by 28. And you can get your value, your decimal. However, one of the things that's very helpful is the fraction utility on these. If you hit alpha y equals, it brings up a little menu, and then you can just put in your values that you have on your paper. This is probably the best thing you can do to avoid not making any calculator mistakes. So alpha y equals, and we get the same value. Okay? I would recommend alpha y equals always. So sine of the angle is equal to this decimal 0.915. But we need to take the inverse of that. So the inverse of that decimal is 11 degrees. So angle A is 11 degrees. And that's how we use the law of sines, to find a missing angle. The important thing to keep in mind also was that since you are looking for an angle, you have to remember to use the inverse at the end of your problem. Let's look at a problem where I don't give us the picture. So, I'm going to draw my triangle. I've got A, B, C, and I did that in a clockwise position. Angle B is 12 degrees. Side length of B is 5. Angle C is 72. So I was able to set up all of that information for us. And then might as well make this in chart format as well. And they want me to find C. So as you can see, I really organize it really well here. I put B's across from each other and C's across from each other. So when it comes to setting up this problem, we know we're looking for side C. We have a situation that this is an angle-side triangle. Okay, always good to start recognizing that, angle-side. So I don't have to worry about an ambiguous case here at all. And we're going to set sine of B, so 12 degrees, divided by the side length of 5 is equal to the sine of 72 divided by side C. Figure out what are we going to multiply. We're going to multiply our numbers that we know, and we will divide by sine of 12. So C will look like 5 times sine of 72 divided by sine of 12. And that's what we're going to put into our calculator. So alpha y equals, to bring up the fraction menu, 5 times sine of 72, and then move to your denominator and put sine of 12. And that is C. Now this is an actual length, okay? So I don't put a degree symbol on it. I don't have to do an inverse or anything like that. And there we go. So drawing a triangle, clockwise, label your things, make a chart, set up your proportion, solve. Here we go. We want us to find C. To draw my picture. Angle C is 121. Angle B is 23. And side A is 24. They want us to find this little bad boy. So we have an angle, we have a side, and we have an angle. So this is an ASA. We do not have to check for ambiguous case here. So let's make the chart. So angle B is 23. degrees. I'm looking for side B. I don't know that. Angle C is 121. Uh-oh. I don't know side C. And angle A and side A is 24. I do know that one. So in all the problems so far, we've always had a corresponding pair of angles and sides. We don't have that. If I knew angle A, then I could have my corresponding pair. But I do know angle A. I just have to think. This angle and that angle and that angle, angle A, B, C, all should add up to 180 degrees because of a triangle rule. So the triangle rule says that if we take 180 degrees minus the angles we know, 23 and 121, we will get that third angle. 180 minus 23 minus 121 is 36 degrees. So that is our missing angle. Now we have a corresponding pair. We can set up our law of sines. So sine of 36 degrees, which is angle A, divided by its corresponding side, 24, equals. Which one do they want us to find? They want us to find C. So we're going to focus on that pair. Sine of 121 divided by side C. We're looking for a side, so we won't have to use inverse. So we're going to multiply those, and we will divide by that. So C is going to equal 24 times sine of 121, all divided by sine of 36. Let's go to our calculator. Alpha y equals 24 times sine of 121 in the numerator, sine of 36 in the denominator, and this side length is 34.99, so we'll just round it to 35. And that so far is the basics of finding a law of sines problem. Okay. This question is kind of what it's going to be looking at for a 3.0. You have some information, you need to draw a picture, and ultimately you won't know whether it's law of sines or law of cosines that we're going to use, but we got to find everything. So they told me 4.56 for the side. They told me the corresponding angle is 43 degrees, 57 degrees, and I have to find everything else. But what order I do that in is really up to me. Draw my triangle so I can classify it. They told me angle A is 43, side A is 4.56, angle C, so BC, is 57. So this is an A, this is a SAA. So side, angle, angle, clockwise motion. And I don't really skip anything. So not ambiguous case. So, I mean, let's find side C first. We don't have to do that first, but might as well. So, and we've got our corresponding pair for A, so that's going to help us. That's one of the signs that law of sines is okay to use. So sine of 43 degrees over 4.56 is equal to sine of C, 57, divided by C. I'm going to do my calculator magic. I'm going to multiply 4.56 times sine of 57, and then I will divide by sine of 43. 4.56 times sine of 57. Make sure you're in degree mode. Divide by sine of 43. And C is, sorry to divide, 5.0 or 5.6. Cool. Then I might as well move on to angle B. That's a triangle rule. 180 minus 43 minus 57, because all the angles have to equal 180. And that would be 80 degrees. And then to find side B, we just set up another law of sines. We're going to use angle A's corresponding ratio. So sine of 43 over 4.56 equal to sine of 80 over B. Multiply the numbers we know, multiply that pair first, and divide by that pair. 4.56 times sine of 80, take that and divide by sine of 43. And B is equal to 6.58. So we'll make it 6.6. And we have solved the triangle. Now, we're going to add some more complexity to these solving triangle problems, but in the end, this is kind of what you can expect to be doing, is finding all the information in this problem. The last problem, the guided practice problem, I'd like you to do on your own and then show me, and then from there you can start working on the independent practice. Thanks for watching. Sorry for the length of this video, and good luck.